I welcome everyone to this video. I am Mr. Ish. Thank you for joining me. Y equals cosine x, y equals x. If we were to graph these, what would be the intersection point of both of these functions? X and y axis 0, 1. Cosine of 0 is equal to 1, and here's a graph of cosine x. 0, 1 is a y-intercept. Not too hard. Y equals x, everybody knows it to be right here. Here's your origin. You have an intersection point. How can we calculate that? You know this point right over here is pi over 2, 0, because cosine of pi over 2 is an x-intercept, it's 0. Here you have 0, 1. We're interested in this intersection point. What's this x, y? We can easily do it. It's going to require a bit of a out-of-the-box thinking. If you were to make both of these equations equal to each other, cosine x is equal to x, you can't really solve for x because one x is so inherently tied to your trigonometric function, you can't separate it. So you have to come up with a different technique, and there is a different technique. It requires a little bit of calculus, but it's not hard. If you think about here, this formula, a certain function has a series and it can be determined as n equals 0 up to infinity. I'm looking here at the nth order derivative receiving a 0 value, x to the power of n divided by n factorial. If you were to run the cosine through this formula, you could develop a certain polynomial series for the cosine, and then you can make both of these polynomials equal to each other and solve for x. But you need to worry about this, the nth order derivative. That requires a little bit of calculus. You know the 0 order derivative of cosine is your original function, it's cosine x. But you're always putting a 0 based on the formula. From n equals 0 to infinity, you have a certain sum, nth order derivative always receiving a 0 value, x to the power of n divided by n factorial. These n values are coming right here. You're always putting a 0, and cosine of 0 is equal to 1. When you do your first order derivative, what's the first order derivative of cosine? Here, just take my word for it. When you do the derivative of cosine, it's equal to a minus sign. When you do the derivative of sine, it's equal to a positive cosine. And you can always review reference books for this. The derivative of cosine is always equal to a minus sign, but you're always putting a 0 because it says the nth order derivative receiving the value of 0. Sine, positive or minus, always equal to 0. The second order derivative is the next derivative of minus sign. The derivative of sine is cosine, the derivative of minus sign is minus cosine, but you're putting a 0 and you'll get here a minus 1. The third order derivative, and we'll go to the fourth and we'll stop. The third order derivative is the next derivative of this. The derivative of cosine is a minus sign, but the derivative of minus cosine will be a positive sign, but you're putting a 0 and it zeroes out. The fourth order derivative is the next derivative of this, which is the fourth order derivative of your original function. What's the derivative of sine? It's cosine, but you're putting in a 0 and it's equal to a 1. When you start putting in these values, all we've done here is determine this part. We still have to do x to the n and n factorial in the denominator. But as you start developing the series, what do you get? Your first term has a coefficient of 1. That's your nth order derivative with a 0. 1 times x to the power of 0 divided by 0 factorial. Your next term will be this, minus sign of 0, which is a 0, but then you have x to the power of 1 over 1 factorial, and then your next term will be a minus, and then you'll have a minus, then you'll have x to the power of 2 over 2 factorial, then you're coming right over here, you'll have a plus 0 x cubed over 3 factorial, then you'll be coming over as a positive 1, so you have a positive 1 x to the power of 4 over 4 factorial, and you'd go on and on. You know we went here to the n value of 4, you would go normally up to infinity. This technique I'm showing you is a good approximation. You'll get a very good approximation of this intersection point. It won't be exact, but you'll have a very good approximation. You will require an algebra application system, online system, to help determine the exact value here of your intersection point, but that would not be within the scope of what we can do. It would require computer algebra software to determine these type of function intersection points. Anyhow, let's look at this. This right here is my cosine function series. It's my power series. If you open this up, what do you have? X to the power of 0, 0 factorial is a 1. Then you have a 0. Then you have a minus x squared over 2 factorial, which I write as 2. This here is a 0. Then you have a x to the 4 over 4 factorial, which I write as a 24, and you would go on and on. Anyhow, let's clean this out. When I clean this out, what am I seeing? I'm seeing here cosine x in terms of its series representation is equal to 1 minus x squared over 2 factorial plus x to the 4 over 4 factorial. But we don't need this anymore because we've used it. It has served its purpose. We have essentially converted cosine, a trigonometric function, into a polynomial function. By using that formula, we've determined here what is called a Maclaurin series of the cosine. I'll write this name out and you'll see it in the video information, Maclaurin series. Anyhow, we're determining an intersection point. cosine x must be equal to the other function, but cosine x is equal to this 1 minus x squared over 2 plus x to the 4 over 4 factorial, which I can write as a 24. Then you'll take it on and on. You'd have a minus, plus, minus. If you look here at the pattern, you can easily start determining it. You're looking here by even, and it's positive, minus, positive, minus. Your next term would have been minus x to the 6 over 6 factorial. Then you'd have had plus x to the 8 over 8 factorial. Then you'd have minus x to the 10 over 10 factorial. And here you'd have x to the 12 over 12 factorial, and you can take it on and on. But I'm looking here at these items which I derived, but I'm really interested only in the first two terms. Cosine x is equal to 1 minus x squared over 2, and everything else, but it's kind of meaningless, is equal to x. Get rid of the denominator, cross multiply. I have a 2 minus x squared is equal to 2x. And now I have a quadratic function, and let's deal with it. Push everything onto one side. I have a minus x squared minus 2x plus 2 equals 0. You can say you have x squared plus 2x minus 2 equals 0. You have here a quadratic equation for which we will now bring out the quadratic formula. A, b, and c, you know, minus b plus minus square root b squared minus 4ac over 2a. What is my b? It's a minus 2. It's a 2, but minus 2 plus and minus square root b squared, which is a 4, minus 4 times 1 times minus 2 divided by 2 times 1. When I solve this out, what do we have? I have here a minus 2 plus and minus root of 12. 4 plus 8 is a 12. Root of 12 is a 2 root 3 over 2. When I simplify it, I have minus 1 plus and minus root 3. When I look here at this diagram, I'm looking at the positive x values. I'll only do minus 1 plus root 3. That is equal to x. But x is equal to y is equal to x. Therefore, y is equal to minus 1 plus root 3. What is your intersection point? You have it. We will bring out the calculator value momentarily. This here will be minus 1 plus root 3, comma, minus 1 plus root 3. Or you can say root 3 minus 1, comma, root 3 minus 1. But that right there is your intersection point. What does it mean in terms of calculator? Do square root of root 3 minus 1. I'm getting here 0.732, comma, 0.732. That's your intersection point. 0.732, comma, 0.732. But if you were to use a computer algebra software program which would give you the exact value, you would find it to be 0.739, comma, 0.739. One is the value of x, the other one is the value of y. We are here 0.732, but the exact intersection is really 0.739. This approximation is very good. What's the margin of error? You can easily calculate it, and you'll see it to be minus 1%. Take the value you've calculated, minus it from that value, divided by your value, which is the correct value, and multiply by 100. You have that, minus 1%. We are underestimated by 1%, but we are off by 1%. Our value here is less than that, hence a minus, but it's 1% off. My margin of error is really good. The acceptable margin of error is 5%. We've used here basic calculus to convert a trigonometric function into a polynomial function, and you saw that polynomial function. The first part was 1 minus x squared over 2, then you had plus x to the 4 over 24, and then you could take it on and on. This was our cosine converted into a polynomial. I only looked at the first two terms. If I brought in the fourth exponent term, we would get closer and closer to the accurate value, but then dealing with the x to the power of 4 and doing algebra with that is difficult. We took the first two terms, we equaled it to x, as you see right over here, and we solved using basic quadratic formula, and we were done. Thank you for watching.